Good morning, everybody. Today we are going to discuss 8051 microcontroller, and the same course can also be labeled as embedded system and programming. Before I start, let me share my screen. Okay. So, in fact, at Dr. Babasaheb Ambedkar Marathwada University, I am teaching this course 8051 microcontroller to MSc Physics second semester student and MSc Electronics second semester student. As far as MSc Physics is concerned, they have the title of the course 8051 microcontroller in their curriculum. And as far as MSc Electronics is concerned, they have the title Embedded System and Programming of this title in their curriculum. Okay, anyway. In fact, this is 2 credit course, and I have decided to prepare this content for my student. These are the list of learning outcomes which we have included in the curriculum, but we don't need to explain those learning objectives. And these are going to be learning outcomes. And this is how the course content is going to be. Like this course at 051 microcontroller has 3 different units. I mean, different chapters. The first chapter essentially deals with the fundamental concept of microcontrollers, the particularly fundamental concept. And then the second chapter deals with data transfer and logical group of instructions. And third chapter deals with another 3 group of instructions like arithmetic instructions, jump and call instructions. And in fact, like we are going to have the programming practice in chapter third. And these are the different learning resources which student can use to get this course prepared. Let us start with unit 1, 8051 microcontroller. uh, in fact, uh, basically whenever we are studying microcontroller, we need to understand what is the difference between microcontroller and microprocessor. The fundamental difference between microprocessor and microcontroller is going to be, you can see here, as far as the microcontrollers are concerned, CPU along with all peripheral devices, they are going to be on single chip. So whenever we are having CPU along with all peripherals on single chip, that device is nothing but microcontroller. And you can see this is side by side comparison of microprocessor and micro controller. You can see, as far as the microprocessor is concerned, we have a CPU, because whenever we are talking about microprocessor, it is essentially central processing unit, the CPU. CPU is nothing but the microprocessor. So in case of microprocessor, you can see CPU here, and all other peripheral devices are not on single chip. They have only CPU on chip. Whereas in case of microcontroller, we have CPU along with all the peripheral devices on single chip. So this is the main difference between microcontroller and microprocessor. And this is the reason why these days microcontrollers are being widely used for many applications. Like whenever we want to do the interfacing of any devices, whenever we want to do automation, particularly either home automation or office automation, microcontrollers are being preferred because we don't need to have extra peripherals connected. And there are certain other advantages as well, and that is the reason why microcontrollers are being preferred over microprocessor for any sort of automation application. Now, let me tell about different the types of microcontrollers. There has been like 2 different manufacturers of microcontrollers. Intel microcontrollers and Motorola. Intel is one of the very famous company of manufacturer of microcontroller, and you can see there are different classifications. Like we start with 8-bit microcontroller, and 8051 microcontroller is example of 8-bit microcontroller. And then we have 16-bit microcontrollers and so on and so forth. As far as Motorola is concerned, it is again like these are three examples of 8-bit microcontrollers, and you can see that if some example of 16-bit microcontroller, 32-bit microcontroller. So in this is the side by side comparison of two different manufacturers, Intel and Motorola, which has right, we start, like, of course we started from 8-bit and 16-bit, 32 bits, and so on and so forth. Now, what are the different necessary tools for microcontroller? CPU is going to be very important, like central processing unit. This is going to be one of the integral part of microcontroller. Then we have input output devices, because we need some input devices to feed the data, and whenever we are going to process the data, we need some output devices. As far as buses are concerned, this concept of bus is same in case of both microprocessor as well as microcontroller, because there are three different buses which we are going to have in case of microcontroller as well as microprocessor: data bus, address bus, and control bus. The data bus is nothing but the group of wires which are being used to transfer data from one location to another location, and the address bus nothing but the group of wires which are being used to transfer the addresses from one location to another locations. And the control bus essentially is a group of wires which is being used, or which are being used to transfer the control signal from one part of microcontroller to another part. Now we have a memory, because RAM and ROM are the integral part of any microprocessor as well as microcontroller. The only difference is going to be, in case of microprocessor, we have ROM and RAM outside the processor, whereas in case of microcontroller, we have ROM and RAM integrated on the same chip. This is one thing, like like truly speaking. But let me tell you one more very important thing. Whether it is microcontroller or microprocessor, मतलब माइक्रो प्रोसेसर हो या माइक्रो कंट्रोलर हो, आपको मैं बताऊं सभी स्टूडेंट के लिए एक इम्पोर्टेंट, बिकॉज अल्दो जैसे कि हम कहते हैं कि माइक्रो प्रोसेसर में memory and peripheral devices are outside the CPU, but let me tell you, and then microcontroller में हम कहते हैं कि everything is on single chip. आपको एक क्लैरिटी में मुझे बतानी है सभी स्टूडेंट के लिए, वो ये है कि whether it is microcontroller or microprocessor, it has got internal RAM as well as ROM. Like even microprocessor also has internal RAM and ROM, and microcontroller also has internal RAM and ROM. When we talk about the peripheral on single chip in case of microcontroller, that is something which is the bigger memory size, because whatever internal ROM RAM we have with microprocessor, it has got limited space. Internal ROM and RAM has limited space, whereas we don't we as whenever we are going to program microprocessor, we need little bit more space, and that is why this external ROM and RAM is going to be there, which is connected to any microprocessor. On other hand, in case of microcontroller, they have like internal within microcontroller, and as well as they have on a single chip also they have some external, but still it is a part of microcontroller. So that memory is going to be little bit higher on side as far as the microcontroller is concerned, whereas whatever memory, internal memory we have in case of microprocessor, which is going to be very very limited. And that is the reason why usually we call the CPU along with all peripherals on single chip, that device is being referred as microcontroller. But truly speaking, ये जो रोम एंड रैम की बात मैं बता रहा हूँ, वो माइक्रो प्रोसेसर में भी होती है इंटरनल, बट दैट इज very very limited. Then we need a timer circuit, because whatever the functioning we are expecting from microcontroller, that need to be that can be executed, like whatever programs we'll be feeding, whatever processing we are expecting from microcontroller, that need to be controlled by timer circuits, and that it is going to be there. Interrupt is going to be integral part of microcontroller as well, because interrupt terminals are very very important. Interrupt control terminals are very very important. जैसे कि माइक्रो प्रोसेसर में जिन जिन स्टूडेंट ने माइक्रो प्रोसेसर की पढ़ाई की है उनको भी पता होगा कि माइक्रो प्रोसेसर डू हैव सम इंटरप्ट कंट्रोल टर्मिनल, बिकॉज इंटरप्ट कंट्रोल टर्मिनल की जरूरत क्या होती है, क्योंकि मान लो एक कोई प्रोग्राम हम एग्जीक्यूट कर रहे हैं, जैसे कि आम लाइफ में भी, अगर मान लो कोई, अगर मैं फॉर एग्जांपल आई एम टीचिंग स्टूडेंट इन द क्लास एंड समबडी नॉक माय डोर, अगर किसने अगर दरवाजा अगर नॉक किया है तो आई नीड टू अटेंड दैट, बट व्हाट व्हाइल अटेंडिंग दैट व्हाट आई विल बी डूइंग, आई विल बी कंप्लीटिंग माय टास्क ऑफ, लाइक जो मैं बता रहा हूँ मैं कंप्लीट करूंगा, एंड देन आई विल बी गोइंग टू द पर्सन हु हैज नॉक माय डोर, तो उनको अटेंड करके फिर से मैं मुझे लौटना पड़ेगा. सो व्हाट डज इट मीन? इट मीन्स दैट in our day to day life also, we always keep that interrupt option open, and same thing is true with microprocessor as well as microcontroller too. जब कोई प्रोग्राम अगर एग्जीक्यूट हम कर रहे हैं, तो in meantime we might need to interrupt microcontroller or microprocessor in between, and therefore interrupt control terminals are very 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 much needed. And then we have some serial port as well as parallel port, बिकॉज ज्यादातर डेटा जो है हम पैरेलल मतलब पैरेलल पोर्ट से ही बाहर भेजते हैं माइक्रो कंट्रोलर से, और पैरेलल पोर्ट से ही इन करते हैं. बट देर आर सम एप्लीकेशंस इन विच the data need to be transferred from microcontroller to outside world, and similarly from outside world to microcontroller through serial port. Therefore the serial port is going to be important tool or important component of microcontroller as well. There are two different architectures of microcontroller: von Neumann architecture and Harvard architecture. Now, if you look at the von Neumann architecture, you can see here the program and data memory is together. Of course, buses concept of bus is going to be same, because data bus need to be bidirectional. Address bus is always unidirectional. जो सीपीयू से मेमोरी तक जाए, मेमोरी की तरफ जाएगी, बायडायरेक्शनल नहीं होगी. But if you look at the Harvard architecture, rest of the thing is same, but only thing is program and data memory is different. Like they are differently placed within the architecture. This is the main difference between von Neumann architecture and Harvard architecture. Now I'm going to tell you some introductory concept of microcontroller. So as I mentioned earlier, it is a single chip computer or a CPU with all peripheral like ROM, RAM, IO, timers, A to D converter, etc. on single chip, on the same chip. It means whenever we have a CPU along with all the peripheral, that becomes a small computer, and that is what we call as a microcontroller. Because microcontroller is also a computer, it's a dedicated computer. Microcontroller is meant to be a more self-contained and independent and function as tiny dedicated computer. As I mentioned earlier, this is very, very dedicated device. Originally, 8051 microcontroller were developed using NMOS technology, but the use of battery-powered devices and their low power consumption lead to uses of CMOS technology, which is famous for its low power consumption. What is the reason? The reason being because, as it is mentioned in the third bullet, that earlier, like when we started 8051, when 8051 microcontroller started manufacturing, initially they used to be developed using NMOS technology. But NMOS technology has some disadvantages. Power consumption unka bahut zyada hai, and CMOS has a less power consumption, very low power consumption. Therefore, later on, by using CMOS technology, 8051 microcontroller started manufacturing. Majority of modern 8051 microcontrollers are silicon IP cores, intellectual property cores, but the discrete 8051 microcontroller IC are also available. So this is how this is about some introductory part, like majority of modern 8051 microcontrollers are using silicon IP cores, and which has got certain advantages. And because of their low power consumption, smaller size, simple architecture of 8051 cores, and use field programmable gate array, because this is again like very important concept: field programmable gate array and system on chip. These two concepts are being widely used in case of the modern microcontrollers, particularly 8051 microcontroller. And as a result of that, power consumption has been very, very less. Let me tell you the features of 8051 microcontroller. It is useful and very small computing. It is useful for small computing tasks. Like whenever we have a tiny applications, in those for tiny application, you don't need to you have a very huge hardware. So that can be done by 8051 microcontroller. It is adequate for many control and monitoring applications. Packaging with RAM, ROM, timers on chip. This is again one of the very important feature of 8051 microcontroller. It consume very less power. It can be easily upgradable. This is again very important aspect of 8051 microcontroller. And availability of tools of microcontrollers such as protests, simulators, and compiler. This is again like as far as 8051 microcontroller the tools are concerned, they are easily available. This is again like very important feature of 8051 microcontroller. This is like a very important block diagram of 8051 microcontroller. You can see here we have a CPU, as I mentioned earlier. The CPU along with all peripheral chips on single chip, nothing but the microcontroller. You can see this is CPU, and we have got ROM, RAM, IO ports, bus controller. This is the control which by which the serial data can be transferred from microcontroller to the outside world, and also we can receive data from outside world. And these are the timer circuit. And this oscillator, because this oscillator, whatever crystal which we will be connected here, this oscillator circuit will be responsible for deciding the frequency of microcontroller. And this is interrupt control, because as I mentioned earlier, whatever interrupt control terminals are there, they need the controller. And so therefore this interrupt controller terminal क्या करेगा, जो भी बाहर से इंटरप्ट हम माइक्रो कंट्रोलर को करेंगे उसको पूरा कंट्रोल करने की जिम्मेदारी होगी ये इंटरप्ट कंट्रोलर की. रोम एंड रैम, क्योंकि जो मॉनिटर प्रोग्राम, जैसे कि आप स्टूडेंट ने जो लैब में प्रैक्टिकल जो स्टूडेंट करते हैं, so whenever you will be switching on your microcontroller chip, there will be some display, because that display depends on like which manufacturer of is who has developed that kit. That it depends on, because let's say like I am the manufacturer of one particular microcontroller kit, I can decide what should be the display of that. So I can write like for example, Dr. Babasaheb Ambedkar Marathwada University, or Intel microcontroller, or 8051 microcontroller. That kind of display can be there on the display unit. So it all depends on what kind of monitor program I have written while manufacturing that kit. So ROM is going to be responsible for that. And whenever we are using, whenever we will be programming microcontroller, so we need a scratch pad memory. RAM is nothing but a scratch pad memory, and we have 128 byte scratch pad memory as far as 8051 microcontroller is concerned. Bus control, like all four buses, address bus, database and data bus and control bus, ये तीनों बसेस को कंट्रोल करने के लिए बस कंट्रोल लॉजिक होना जरूरी है. So this bus control block is going to control the flow of data, flow of addresses, and flow of control signal. Similarly, this IO ports, 8051 has four IO port 0, port 1, port 2, and port 3. All IO ports are bidirectional ports. And as I mentioned earlier, this is the serial data control, because as I mentioned earlier, sometimes we need to send the data through serial port, and we need to receive the data from serial port. For that purpose, we need serial control block inside the microprocessor. So these are the microcontrollers. So these are the important blocks of 8051 microcontroller. Now this is like more detailed version of 8051 microcontroller block diagram. I call it as a original 8051 microcontroller. Why? Because here more detailed blocks have been shown. You can see here again like 805. This is CPU. This is 64 kilobyte bus expansion control, because whenever we will be expanding bus, we need that provision as well. So this is also there. If you look at the earlier block diagram, वहां पर ये पर्टिकुलर ब्लॉक नहीं था। तो जब हमें बस का एक्सपांशन करने की जरूरत होती है, उसके लिए हमें ये 64 किलोबाइट बस एक्सपांशन कंट्रोल की जरूरत होती है। देन दिस ऑसिलेटर एंड टाइमिंग, एज आई मेंशन अर्लियर, जो क्रिस्टल हम लगाएंगे, that will decide what would be the operating frequency of 8051 microcontroller, and accordingly microprocessor की speed decide होगी। दिस इज प्रोग्रामेबल आईओ, जैसे मैंने बताया कि ये आईओ कंट्रोल ब्लॉक जो है, इट इज हाईली प्रोग्रामेबल। वी हैव 4 ports which can be programmed depending on our requirement. All ports can be either programmed as input port और आउटपुट पोर्ट, और इन उसमें से ऐसा कर सकते कि एक पोर्ट हम इनपुट के लिए कॉन्फ़िगर कर सकते हैं, एक पोर्ट आउटपुट के लिए कॉन्फ़िगर कर सकते हैं। And then this is programmable serial port full duplex UART synchronous shifter. So this is like more I mean detailed description of that serial port, like which is being used to control the flow of data serially from microcontroller to outside and outside the microcontroller. We do have two 16-bit timer event counters, which is these counters are being used to control the internal operation of microcontrollers. And then we have this is 4096 byte program memory, and this is data memory. As I mentioned earlier, here in this particular block, the memory has been segregated into two different sections: program memory and data memory. This is more detail again, like because what if you look at this, हम यहाँ से हमने शुरू किया थोड़ा broader, मतलब यहाँ पर है ना, ये ब्लॉक डायग्राम बहुत डिटेल नहीं है, हमने यहाँ पर important ब्लॉक बताने की कोशिश की। Now here more detailed blocks हमने बताने की कोशिश की। Now you can see here more details of the 8051 architecture. We can call it as a 8051 architecture, because basically आर्किटेक्चर एंड ब्लॉक डायग्राम इज सेम, क्योंकि ब्लॉक डायग्राम में भी हम क्या करते हैं, जो जो इंटरनल ब्लॉक्स जो है वो हम बताने की कोशिश करते। बट इफ यू लुक एट दिस डायग्राम, यहाँ पर हमने क्या किया, खाली इंपॉर्टेंट ब्लॉक्स बताए, यहाँ पर थोड़े ज्यादा ब्लॉक बताए, सो दैट हमने क्या किया ना, सिंपल सी शुरुआत किया, एंड देन वी स्टार्टेड गिविंग यू इन डेप्थ अंडरस्टैंडिंग ऑफ 8051 micro. Now this is, we are calling it as a we are calling it as a micro 8051 architecture. The reason for that is here more detailed blocks have been mentioned in this particular block diagram. You can see now here, आप अगर पहली ब्लॉक डायग्राम आपने देखे होंगे तो you must have seen only CPU. Now you can see here what is there inside. Like we have arithmetic and logic unit, because what is the role of arithmetic and logic unit? The role of arithmetic and logic unit is going to be whatever arithmetic and logical operations which are going to be performed by microcontroller, those operations are going to be performed in arithmetic and logical unit. अब ऐसा है कि यहाँ पर रजिस्टर accumulator A and register B is called as a temporary register, and this is accumulator. Important difference between microcontroller and microprocessor, again, like another important difference is going to be particularly 80, थोड़ा सा अगर कंपैरिजन किया जाए तो 8085 माइक्रोप्रोसेसर का थोड़ा सा कंपैरिजन 8051 के साथ होता है, क्योंकि 8051 माइक्रोप्रोसेसर में whenever you will be processing any data, the process result is always going to be stored in register A. That is why the concept of accumulator is there in 8085 8085 microprocessor, whereas in 8086 we don't have that concept of micro accumulator. The concept of accumulator which was there in 8085 microprocessor, the same concept is there in 8051 microcontroller as well. यहाँ पर भी ऐसा होता है कि whatever addition, subtraction, multiplication, division, जितने भी arithmetic and logical operation यहाँ पर होने वाले हैं या हम करने वाले हैं, the process data is always going to be stored in accumulator. लेकिन रजिस्टर बी की जरूरत क्या है फिर, क्योंकि whenever we are doing addition, let us say 05 plus 05. So whenever we are doing addition of 05 plus 05, तो हम क्या कर सकते हैं, 05 can be transferred to accumulator, 0 another 05, like 0, let's say 05 plus 06. So 05 can be transferred to accumulator, 06 can need to be transferred to some other register. तो वो रजिस्टर कौन सा होगा, दैट इज गोइंग टू बी ए टेम्पररी रजिस्टर. तो यहाँ पर ये टेम्पररी रजिस्टर बताया गया है, रजिस्टर बी. So register B is temporary register. A is accumulated. It is a very special purpose register as far as 8051 microcontroller is concerned. Program status word is going to decide because in case of 8051 microcontroller, there are certain flags. I'm going to tell you the details of those flags later. The flags are going to be like, what is like, program status word is the register which is going to मतलब उससे हमें पता चल सकता है कि माइक्रो कंट्रोलर में क्या हो रहा है, मतलब व्हाट इज द स्टेटस. मतलब अगर मान लो एडिशन है तो कैरी जनरेट हुआ है या नहीं, प्रोसेस रिजल्ट जीरो है क्या, जीरो फ्लैग सेट हुआ है क्या. सो ऑल दोस फ्लैग्स, इनफैक्ट वी डोंट हैव जीरो फ्लैग एज सच इन 8051 माइक्रो कंट्रोलर. क्या क्या फ्लैग्स है मैं आगे आपको बताने वाला हूं. बट एज ऑफ नाउ, प्रोग्राम स्टेटस वर्ड is the register which is being used to understand what is happening, what is there, what is happening inside the microcontroller. There are some special function registers which we call as a RAM. उसका डिटेल मैं आपको आगे बताने वाला हूं, because there are different banks as far as 8051 microcontroller is concerned. There are different bank 0, bank 1, bank 2, bank 3. These all are special function register part of RAM that I'm going to tell you later. This is 8-bit data bus and address bus, क्योंकि एड्रेस बस तो 16 बिट की है and data bus is going to be 8 bit. This is internal ROM which we have, 16-bit address bus, and this is 8-bit data bus in fact. And program counter, in fact, PC is going to play a very important role. Like whatever program counter is being used to keep a track of program execution. मतलब जो भी प्रोग्राम, जैसे कि मान लो हमारे पास 5 लाइन का प्रोग्राम है, लेट्स से लाइक द प्रोग्राम स्टार्टेड फ्रॉम मेमोरी लोकेशन 1000 से लेकर 1005 तक अगर मान लो हमारा प्रोग्राम है. So the problem is whenever you will be feeding program to the microcontroller, तो माइक्रोकंट्रोलर को कैसे पता चलेगा कि हमें 1000 से ही प्रोग्राम एग्जीक्यूट करना है. वो कैसे होगा, जब हम माइक्रो कंट्रोलर कीट पर जब कोई प्रोग्राम फीड करते एंड देन वी व्हेन वी एग्जीक्यूट के प्रोसीजर में ही स्टार्टिंग एड्रेस देने का एक स्टेप है, बिकॉज in the process of execution you need to feed the starting address. So when as and when you feed the starting address, it goes to the program counter. So प्रोग्राम काउंटर में जो भी एड्रेस होगा वहां से प्रोग्राम एग्जीक्यूट होना शुरू होगा. सो दैट इज व्हाई program counter plays very important role in 8051 microcontroller. So program counter used to it is being used to keep a track of program execution. So this is the program counter. DPTR is a 16-bit register, because whenever we will like to access external memory, क्योंकि internal memory जो है वो तो 8 bit की है, बट उसका एड्रेस, इंटरनल मेमोरी का एड्रेस बेसिकली 8 बिट का है. इसीलिए यहाँ पर 8 बिट डेटा बस एंड एड्रेस बस क्यों लिखा है, क्योंकि व्हाट एवर इंटरनल मेमोरी इज कंसर्न, 8051 का जो इंटरनल मेमोरी है उसका एड्रेस जो है 8 बिट से डेसिग्नेट होता है, और एक्सटर्नल मेमोरी जो है दैट इज बीइंग उसका जो है 16 बिट से होता है. सो वेन एवर we would like to address access the external memory, at that time we need 16-bit register. So DPTR is being used for that. System, this block is very very important. This block is being used to control the timing inside timing of the, मतलब टाइमिंग का मतलब क्या है ना, जैसे कोई हमने एक इंस्ट्रक्शन दिया है, फॉर एग्जाम्पल हम डेटा ट्रांसफर करना चाहते हैं रजिस्टर बी से ए तक. तो whenever we want to transfer data from B to A, तो हमें क्या करना पड़ेगा, रजिस्टर बी को हमें इनेबल करना पड़ेगा, रजिस्टर ए को इनेबल करना पड़ेगा, एंड देन डेटा कैन बी ट्रांसफर फ्रॉम रजिस्टर बी टू ए. सो फॉर दैट पर्पस कंट्रोल सिग्नल्स नीड टू बी जनरेटेड. सो जो भी हमारा इंस्ट्रक्शन होगा, 8051 माइक्रोकंट्रोलर का इंस्ट्रक्शन होगा, when that instruction goes inside the microcontroller, this timing and control unit, the system timing unit will take care of decoding that instruction. Decoding का मतलब क्या है कि जो भी instruction होगा उसका accordingly control signals are going to be generated and data is going to be transferred from one place to another place. And then we have this block is also going to control the interrupts and the data buffer memory control. इसीलिए क्योंकि whenever we will be transferring data from microcontroller to outside memory or from outside to microcontroller, we need data buffers. क्योंकि वो टाइम बिंग वो डेटा वो बफर्स में स्टोर करना जरूरी होता है, and that is why data buffer controls are there. You can see these data buffer controls. And all these terminals like this EA, ALE, ESEN, this I'm going to explain these control terminals in detail in case of time pinout diagram of 8051 microcontroller. This is what I was talking about. You can see there are um, uh, four banks: register bank 0, register bank 1, register bank 2, and register bank 3. And in fact, like we can address these banks. There are certain banks which can be addressed in parallel, and we can also, there are some there are some banks which can be bit addressable also. I mean, individual bit also can be accessed, so that also can be done. That I will show you and I will tell you in detail in maybe in the next slides. These are some special function registers. I will explain all those special function registers because these are very important terminals, which are being which plays very important role, and that I will be explaining all those. Uh, all those concept in detail while explaining the pinout diagram of 8051 microcontroller. And these, as I mentioned earlier, there are four ports: port 0, port 1, port 2, and port 3. But you cannot transfer data directly to the port because there has to be latch, because before sending data to port, the data need to be loaded into the latches, and therefore you can see prior to the port there are another blocks which are being referred as the latches. These latches plays very important role, and these terminals I will be telling you in more details while discussing the pinout diagram of 8051 microcontroller. I think we will stop here today because the rest of the thing I will be telling you in detail in the next lecture. Thank you very much.